I'm Danny. This is Suresh. Welcome to our talk, Nomad at Target, scaling our microservices across public and private cloud. Thanks for being flexible and being here. I know it was sort of, it's like right before lunch and the schedules got a little messed up, so thanks for being here. Also, just really quick, there is no official Q&A, so I just want to make sure Suresh and I will both be around afterwards for questions, and we also put our Twitter handles here. Both of us will monitor our phones. If you have any questions or anything, we're happy to respond, whether it's today or 6 months from now. If you have any questions, feel free to reach out. So real quick, before we jump into everything, just a quick overview of what we're going to talk about. So Suresh and I are both going to introduce ourselves. I'll give a little bit of background on Target and what Target's been working on recently. Some of you may not be familiar with Target as it's a US-only company right now. So we'll talk about that. Then we'll get into Nomad, talk about what problems we had, why we chose to use Nomad, how we architected it, things like that. And then at the end, talk about some of the looking further in the future, how we want to handle it, what we're looking to do, maybe how we want to expand, some things like that. So really quickly, again, I'm Danny. So I'm a principal engineer at Target. I work on the guest fulfillment architecture team. Kind of a weird name, doesn't really explain at all what I do. So that team, we're in Target.com. So if anyone here has used Target.com, if you've ever added an item to your cart, if you've ever placed an order on Target.com, all of the microservices and the platform underneath that, my team supports, automates, scales, etc. And so as you can imagine, the next month or so is going to be very important for us because of Cyber Monday, Black Friday. Previously, I worked on a team called Enterprise Services where we built some APIs at Target, and I graduated from Purdue University in 2011. So go Boilers. I apologize to any Ohio State fans that are here today.
Okay. Hey, good afternoon, all. I'm Suresh Krishnan. I'm a lead engineer working for the same team, guest fulfillment architecture with Danny. I joined Target 2 years back, and prior to it, most of the time I was working in the Bay Area. I'm a graduate from Anna University in India.
So as promised, really quickly about Target. So like I said, we're a US-only retailer. We've got about 1,800 physical stores. We also have Target.com, which as you can imagine has become very important in the last couple years with the growth of e-commerce, with the amount of people that shop online now. And I did want to highlight some of the features that we're working on, and A, sort of as a plug for them, because I think they're really cool, but B, because features like this can be very hard to develop, and it's a big challenge for our technical teams. And so I kind of want to set the stage as in a lot of these features, they're sort of the driver for why we look into tools like Nomad or why we look into tools like the automation, so like Kubernetes, Nomad, like Terraform. These are a lot of those drivers to do that. And so some of those are shipping from stores. So if you order something on Target.com, we'll actually deliver it to you from a store. Same day delivery. So Target recently acquired a company called Shipped, working to do same day delivery there. And then mobile apps, just like Target.com, our mobile apps have become much more popular. And so there's many features that we want to add. We want to scale those out. And so that kind of stuff has become a big challenge for our technical teams. So building on that, Target right now is in a place where we have some challenges. And so Target, as you can imagine, is a very big company. So this is by no means true for every team at Target. But overall, where Target is right now, we have a couple different places where we can deploy and where we manage, and things are sort of inconsistent, I guess you could say. So the first is that Target.com is fully in Google Cloud. Super excited about that. We had Target represented at the Google Cloud Next conference in San Francisco. I think it was in July, if I remember right. We gave some talks there, so if you're interested in hearing about that, interested in hear how we architected that and how we how we run there, different things, I encourage you to check out those talks because it's really interesting. We also have our own data centers. So Target has 2 data centers in Minneapolis. Well, not in Minnesota. They're both in Minnesota. And that's sort of like traditional legacy workloads, things that maybe didn't move to the cloud or some things that maybe haven't been prioritized to move yet. And then the other really exciting thing is that we're deploying to our stores now. And so all of our stores run Kubernetes. And we are working on deploying and doing more and more automation of our actual store workloads, which is it's really exciting, but it's also a big challenge. And so then building on that, I want to talk about like our specific team. So this is talking about my specific team and like the issue that we had. So that's where Target is overall, right? We have stores, we have data centers, we have the cloud. So then there's my specific team, and I want to talk about a specific application that our team has been working on and our team has been deploying. And it actually just went into production last week, which is very exciting for us. But that application has the unique characteristic in that we deploy it to all 3 of those locations. So we deploy it to our store, which is Kubernetes right now, so it has to be in Kubernetes. We also deploy it to our data centers, and we deploy it to Google Cloud. And I have question marks by those last 2 bullet points because we had to figure out where we wanted to run that. We had a lot of choices. We had some flexibility there, but we didn't know like what to do there, right? Because we have Kubernetes in the stores, and then we have the public cloud in our own data centers. And so we needed to decide what to do there. We also had a bunch of supporting microservices. So some like batch jobs, a Spark job that does some stuff against our Cassandra cluster. We also had some like POCs and some UIs and different things that we needed to support as well. So it wasn't just the application, but it was many different microservices and a big architecture. And then I wanted to touch quickly on just some things that I wanted to avoid. So this is probably, this is hyperbole, right? This picture, but this was actually built by one of our engineers at Target. But really wanted to avoid extra complexity. Really wanted to avoid having to build something that was totally outside the realm of what our developers currently use, and wanted to like reuse as much as we could. So quickly, I wanted to touch on like what already existed, like what could we have done, so outside of Nomad, right? Like what could we have done that we decided against? So one of the talks that we gave at Google Cloud was on Spinnaker, and so we could have done RPM deployments with Spinnaker. Now there is a bit of a downside there in that I don't know if anyone here has used Spinnaker or uses RPMs, but you have to build a new RPM. You have to bake that image, and you have to deploy it to the cloud. And then based on if you're doing like blue-green or you're doing like canary deployments, that can take a decent amount of time. So it can take like maybe 30 minutes. It could take even longer. And so when you're iterating really quickly, we talk about these new features that Target, that we're trying to provide for Target.com. When you're iterating really quickly and making a lot of changes and testing and stuff, it can be hard, and it can slow you down. The second one is Kubernetes, and this is the most common one that we get asked, like, why didn't you use Kubernetes? They even touched on it in the keynote in the morning, right? One of the big things, the 2 main things that I say when we get asked, why didn't we use Kubernetes? The first is that because of the specific environment that we are in Google, and because of some of the policies that we have at Target, we would have had to run Kubernetes ourselves, and that's very complex, and it's not something that we wanted to take on. And then 2 in that is that we already had an architecture in the cloud. We already had, like our load balancing and our other things all set up. And we didn't want to we wanted to keep as much of that and reuse as much of that as possible. Whereas bringing in Kubernetes would have meant that we change a lot of that stuff over or figure out how to like reintegrate that stuff with Kubernetes. And then really quickly, a couple other ones, Mesos Marathon, that was available. Some teams use that at Target. It was pretty complex when we tested it out. It didn't integrate well with some of the other tools. And then Chef for us, we still use Chef in our data centers, but it's mostly legacy, and we didn't want to move that to the public cloud. So finally, we get to Nomad. So as you assumed, we chose Nomad for this solution, right? So to reiterate, we needed to run an application in our data centers and in our public cloud. And we chose to do that with Nomad. So let's talk about some of the reasons why we chose to use Nomad. The first, and this is probably one of the more important ones to me, is consistency. So like I said, we have to deploy this application in the stores already using Kubernetes, which means that it's already been Dockerized. And so being able to reuse that same binary was very important to me and to our team, because I didn't want to have to build like a new RPM or to have to ask our developers to have a different way to configure the binary that they're using, right? I wanted to keep that same Docker image. The speed of deployment was also very important. Our developers are constantly making changes. They're constantly testing things out. They're constantly like tweaking flags and tweaking different things because of the heavy testing that's going on for these new features. And so giving them that ability to deploy very quickly was very important to us. Another big one was that it integrated directly with Consul and Vault. So like I said, we already had a lot of that architecture in that we already had our secrets in Vault. We already had our architecture already relied heavily on Consul DNS and Consul for service discovery. And so being able to continue to reuse those was very important. And it worked very well. Another thing was multi-region. So outside of our own data center, we have Google Cloud. So right now we're in US Central and US East. Well, hopefully US West to come soon. But the multi-region support was important in that we really wanted the ability to deploy independently to the regions, but also have that federation and have that shared config and the ability to like fail over and all the other things that the multi-region support gets you. And then last was Terraform. I'm sure a lot of folks here use Terraform. We use it heavily to deploy. We already have a well-known deployment pipeline built on Terraform. It's well understood by our developers, and so being able to keep that basically the same and reuse that was very important. So with that, I'm going to turn it over to Suresh for a bit. He's going to get into more of the technical architecture and more of the details around like how we actually deployed this and how we manage it.
Okay. Thanks, Danny. Thanks, Danny, for setting the context. So when we started with the Nomad, decided to use Nomad for our internal use. So we came up with a plan like, okay, let's automate it. And so we started with the basic model, to empower the developers as a self-service model. So we follow the Git process. Basically, the developers can go to Git and author the Nomad job. And then the moment they complete the Nomad job and create a pull request, basically the CI/CD pipeline will come into picture. We have drones that are managing the CI/CD pipeline. So the Terraform plan will validate the Nomad job. And then once it's good, once the commit, then pretty much it applies, and then push the Terraform, the Nomad job to the Nomad servers. So if you see in that architecture diagram, we have the Nomad servers covering both regions, but actually it's pretty much like independent in both regions, and it's federated across so that it is kind of, a gossip among two regions, but it's totally independent. And in this model, if you see that we have a 3-node server cluster in each region, and then one of the server will act as a server leader, basically, and the remaining 2 will be as a server followers. Pretty much follows the consensus model, pretty much documentation out there, following the Raft algorithm. So the moment the job is triggered to be scheduled, basically the Nomad servers will have a consensus to schedule on which nodes to go, basically. And so as an illustration, we have separate Nomad clients that are deployed across 2 regions, the US Central and US East. And then based on the consensus among the servers, the job will be scheduled in any of the nodes, basically. And so pretty much here, the Nomad icon, what we indicates, it's the Nomad client binary that is running on each of these nodes, and it's totally an immutable agent. And then also another cool feature, which we have it right now in the stage, not in the production, is we have immutable, also preemptible nodes that is pushed across to the VM. So meaning that the stage, we want to make sure we recycle on the cost basis to cut cost, and then it pretty much, adjusts to any of the changes, pretty much transparent to the application running. But right now, we didn't push to the production. It's right now in stage. We have a similar setup for our private cloud. So this is what we illustrated for the production, the public cloud, but similar setup we have for the private cloud as well. So just diving back, because we talked about how we are managing the microservices, the Nomad environment. So once the job is scheduled, what happens behind the scenes? So pretty much as Danny covered about how we're interoperable with other HashiCorp products, because we are heavily using Consul and Vault, one of the features that kind of drove us And so once the job is scheduled, pretty much the console here in this case have the service discovery, basically, for which service is running, because we have multiple services running on the nodes. So, and the Vault provides the application secrets. So in this paradigm, So any request that have to go through, we have an HA proxy that acts as a reverse proxy, and it gets a metadata about the services from the Consul DNS, basically. And the way it flows is like, dynamically it gets the detail, and then it knows how to route based on URI context, basically. Just to magnifying what is there within one of the Nomad client nodes. So pretty much for illustration, so what we have here, it could be any number of services running. It could be a Spring Boot application, or it could be a Golang Docker container application that is running there. It doesn't matter at all. So any request that goes from a user or any application request that comes, it goes through HA proxy, and then once it hits one of the nodes, and then so the request is processed by the respective services. But as we know, microservices are kind of a service mesh. I mean, it has dependencies on calling other services. So we have Fab.io that we deployed as a system job, Nomad system job, where it routes the internal traffic. Any calls to other services, it'll be able to route through Fab.io. Fab.io gets, again, the same metadata about other services from Consul. So pretty much we are dependent on that, and pretty coolly it integrated with that. And also, it also changes, let's say if there is any scheduling, reschedule to different nodes, pretty much HA proxy gets updated, and then pretty much it's seamless and transparent where it's running, pretty much. And we haven't done any kind of config hard coding or any such sort. And one of the other things is like the vault, right? I mean, so is one of the the developers which like adopting Nomad is like the vault, providing secrets, and the application can consume it at the time of deployment. So it can get it dynamically at the deployment time, and then it gets all the other metadata, the application key value pairs from the console. So pretty much seamlessly integrates with our Nomad job. And so pretty much it's how the whole flow we are managing right now. But Fab.io right now we haven't deployed in our public cloud. It's still in the POC phase. We did try other products as well, like Linkerd, Named. And so we, after comparing and the features, we came down with Fab.io, but we haven't deployed in the public cloud yet. What are some of the feedback we got? Because when we rolled out, speed is one of the constraints. We want to get application quickly out there. So speed of deployment is one constraint. So based on our experience with Chef, we learned that it does take time, when we want to deploy any new version or any new application. So this cut short a lot, because the moment you author a Nomad job and commit, pretty much the pipeline takes over and deploys in a matter of minutes. So pretty much fast. So that was one of the key driving factor that developers like this about Nomad. And then the blue-green deployment. So earlier, the way we managed blue-green deployment is at the DC level. And so we try to route traffic to an active, passive mode, and then try to get a new version. So we now this Nomad helps to do it on the same DC level. So we can parallelly get the newer version out, and then slowly ramp down the older version pretty transparently with minimal downtime, basically. That's one of the key advantage we had. Managing application properties. So as we know that the Nomad jobs provides application templates. So basically the application can define their properties there, and any of the dynamic properties can be defined as a console key value, and it can be pulled dynamically. So that's one other key advantage. We don't have to maintain across repositories to manage the application properties. And then the seamless CI/CD integration. So we were able to leverage the existing pipeline, and then we used Terraform for deployment, and it was pretty seamless, and we were able to bring it up to speed. And then pretty much any changes, the developers can take control of any newer version, test it quickly, and then iterate through. All these things go seamlessly and pretty fast. And also, we use the functional UI we made available to the developers. It gives some of the more key insights, basically, how the deployment goes through, how the allocation went through, and how is the resource usage. Because one of the key is they can define the Nomad job, the resource requirement, how much memory and then the CPU, and all so on and so forth. So they can look at how the resource usage is, and then it gives visually how to fine-tune it, the Nomad job to move on. And the ease of use. I really encourage Nomad. I've done the documentation is awesome. HashiCorp has done a good job maintaining the Nomad job description, everything. Each and every stanza are documented with examples. So it's pretty ease of use is very good, and the config visibility. So pretty much one of the requirement is like once deployed, how to look at the configuration details quickly. The functional UI provides that as well. So you can look at what are the configuration parameters we have taken care of, what is deployed and what is out there. If there's any change, they can quickly update the Nomad job and push the changes through the CI/CD, the Git process, pretty much empowering them. And pretty much, so the config visibility is one of the other feedback really the developers like about the tool. And so these are some of the feedbacks which really drove us to move forward. And then currently it's operationalized in a production. And so moving forward, some of the statistics sorry. Okay, so Danny, going to cover about the.
Thanks. Okay, so let's talk about some specific metrics and some of the statistics of our actual Nomad deployment. To start, the picture, I should have updated it. I don't know, I didn't think about it. This is it ended, looks like September 30th, so there's still like 2 weeks or 3 weeks of Git commits. That's what that is the number of Git commits to the repo. So you can see in the beginning of March, that's when we were sort of doing a POC, testing it out, and then around the June, July timeframe, we really opened it up for developers. And so I'm going to be very interested to see how this is for our Terraform repo, by the way, for the number of changes. So I'll be very interested to see what that looks like long term. And then so again, to reiterate, we have Nomad in prod, on-premise and in cloud. We're doing many deployments per day. I don't have the exact numbers because they change so frequently, and depending on if there's a new feature or something breaks, they'll be deploying. You can deploy 50 times a day or once a day. Another thing that's interesting is, so in addition to the app that my team is specifically using, we also have some other teams and some other things running in Nomad. One of the things that I think is pretty interesting is we're actually running a full Elasticsearch, Logstash, Kibana, elk stack in Nomad. We're actually ingesting around 300 gigabytes per day in that cluster. And so we were actually able to bring that up very quickly and Elastic, they provide really good documentation on the Docker images that they use for Elasticsearch. And so it's given us a great opportunity to test out stateful apps in Nomad as well as stateless. And then just really quickly on our clusters themselves, we do have 3 production ones, so one in our data center and then one in each region of the cloud. Right now, we're really only running about 8 agents because we want to get that efficiency of the bin packing, and we want to share the allocations across the agent. Once that will be, I can tell you right now that will be scaled up for peak. Because it just went into production, limited use, it's still a small amount of guest traffic. But that will be scaled up as we move closer to Black Friday and through the holidays. So bringing it all back, right? So what did Nomad immediately provide us? Immediately provide my team, immediately provide the development teams at Target. So the application example that I used, the one really important one was that we went from a POC to production to now scaling up in the next, this week, next week, before Black Friday, all within a couple months. And that was really, really useful for us. And it was amazing to see. And it wasn't just that application. Like I said, we now have an elk cluster. We have some different, we're running some Telegraph ingesting and different things all in Nomad. And it's given us the ability to do some POCs and test some things out very quickly and very easily. The iteration factor was an immediate value add for us in that before we were doing Spinnaker RPM deployments or Chef deployments, and we were unable to test some of these changes and test these new versions of APIs, and we were unable to test them very quickly. And so, moving to something that just allowed us to deploy within seconds was very useful. And then, as I sort of alluded to, we now have multiple teams that are using our stuff. Some teams have seen how quickly that our developers were able to use it and how much they enjoyed it. and they have asked to use it as well. And so we've offered it out to other teams as a, like, hey, you can use this to, to test your stuff, to very quickly get deployed, and to have, a working example of your application. And so that's been, it's been really cool to see. So last thing to talk about is, so what do we plan? What are our plans for the future? What do we want to do with Nomad long term? What else do we want to look at? Things like that. So one of the, and I made this slide before I saw the Nomad 0.9 announcements and stuff, but we did want to look into auto scaling. It sounds like that's going to be included in Nomad at some point soon. But that's one of the things that I really want to look into. And not just auto scaling the jobs, but auto scaling our agents. Because you can auto scale your job up really, really high, but if you don't have the underlying agent capacity to support it, then it doesn't help you, right? Also, so like inter-job dependencies. So a lot of our apps that we deploy are microservices that are highly dependent on other microservices in the same Nomad cluster. And so I think it'd be really cool to see some sort of like job dependency type thing where if one job got upgraded to a certain version, then we can keep another job that only connects to that version. Things like that. We have some like weird version dependencies and stuff that it would be interesting to see. The more accurate resource utilization, Nomad's pretty good at telling you what it's using, but we need to get better at that. Teams still consistently request more than they need, as you usually do. And so we just need to get better at figuring out ways to track that, figuring out ways to go back to those teams and say, hey, like it looks like you're only using a gigabyte and you requested 2 gigabytes. And some of the I think I saw something in the Nomad 0.9 that said that it would even automatically like tell you that. So that would be really interesting. Some things about more ACLs. So right now, if you saw the chart in the keynote about the simple but less secure versus like the complex, very secure, we're probably closer to the simple, not very secure, and that we really just have like one ACL right now. That everything's supposed to go through Terraform, so people don't have direct access, but still want to get better. Want to look into adding the target data center as a region. I think that could be interesting to do. And then last, Consul Connect seems very promising. So as Suresh mentioned, we've tested out FabIO as a like service mesh. We've tested out Linkerd. We've even talked about putting like HA proxy actually inside there. So using Consul Connect to manage that and secure that. I don't know, maybe with Envoy, maybe with HA proxy, maybe with something else. Something that I'm really interested in doing. So yeah, with that, that's everything. There isn't a slide for questions. Like I said, Suresh and I are going to hang out. We'll probably hang out in the hallway, actually. I don't know if they need to like set this up for anything else. So we'll hang out in the hallway. Thanks for coming. Thanks for missing the beginning of your lunch to see this talk. And feel free to reach out. We'll be around. I'm here the rest of the week. So feel free to stop by and talk. Thank you.
Thanks all.